Hey there, thanks for tuning to my channel. My name is Abatan Sheriffdeen, but you can call me Sheriff, and welcome to Excel Island. If this is the first time on this channel, welcome. Don't forget to subscribe to the channel to support what I do on this channel. So I'm a top rated plus freelance data analyst on Upwork. I've had major success on the Upwork platform, and I've been freelancing for the past 2, 3, close to 4 years now. I've been in this freelancing in the freelance world and in the tech world generally. But this is my first year being a full-time freelancer. So I became a full-time freelancer this 2023. And I can say it has been really, really amazing and challenging. And I've been trying to figure out how to make it work better. So what I currently do on my live stream, I've been live streaming for the last 20. Oh, I started live streaming from 11th day, but I've been learning on the Datacamp platform for the past 26 days consistently. So I completed a couple of lessons today. Today will be day 27. And my goal is to go consistently and learn 30 minutes, 45 minutes, 1 hour, 2 hour live streaming. I live stream for 30 minutes, 45 minutes, close to 1 hour. And off live stream, I also do some lessons. And I'm going to be doing that for the next 100 days. So my goal is to reach 100-day learning streak. So I'm trying to upskill myself in Excel, Power BI, SQL, Python for my data analytics career. So currently, I'm learning data in SQL on the Datacamp platform, that is data analysis in SQL, and I'm on the data manipulation section, which is the course 4 in the whole. I think there are up to 12 or 15 courses for over 39 hours under this section of data analysis in SQL. And there's also a project at the end of the course. So I'll be doing that for the next 100 days consistently 100 days. So English is that. So I'll be doing that for the next 100 days. And it has been really been an amazing journey. But currently, I'm facing a little challenge. So I'm currently under this section on this data manipulation, which is the Windows function. And I'm finding it hard to really comprehend. So I've been on it for the past 2, 3, I think close to 4 days now. But I found a resource. I went online and I found this free code camp resource on, I think explaining it much more better than the actual resource on Datacamp than the actual resource. I'm under this section. This is the last chapter under data manipulation, and I've been at it for the past close to 4 days. So I've completed the first 3 chapters, and this is the chapter under Windows function. I've been completed most of the section under it. I just want to make sure I have a good understanding of it before moving away from this section. It's not really maybe perfect understanding, but a very, very solid understanding of how the Windows function works, rather than just going over the query or looking showing the answer or just going over it and having challenge with it in the future when I get to work on the full-time role or when I get to work on the project or something of sort. But I found this resource on how to use Windows function in SQL, and I've been learning it since yesterday. I've even run a couple of queries in my workbench, my SQL workbench. So the actual course is on the actual data camp course is on PostgreSQL. I also have PostgreSQL installed on my system. This is it here. But I actually love the MySQL Workbench interface, kind of cool and amazing. So I've practiced what this guy is saying, so I'll just walk you through it. At least I've understand it to the section of this partition by. So I understand how to use overclocks now, and how to aggregate, how to rank overclocks results without using rank. But I'll show you what I mean. I've not understand it to the partition level, to this partition. What I don't understand yet is this sliding windows using overclocks, window function or overclocks with sliding windows. So I'll come back to that section. But let me just walk you through what I've been able to understand so far about Windows function generally in SQL. So that's what we'll be learning today. So I did this. I talked about this section yesterday. You can watch the live stream for yesterday if you missed that. So we actually created a database from this code that was provided there. I just copied the code and drop it on my SQL workbench. I drop it there and it created this database of students for me with the columns, student ID, student name, department. If I run the first query, so this first query is showing all records from the student table. If I just run that query like this, you can see we just have 12 rows. Very simple database. They're just 12 rows. So So we'll just understand the concept of Windows function pretty well. So there's a syntax of Windows function. We'll dwell on this better. I think I talked about it yesterday. So if you go over the syntax, it's kind of clumsy going over the syntax, but when you start writing the code, when you see the code, you understand better. But the first example is how to use Windows function, which is the most important thing. Knowing how to use them, not just understanding the theoretical aspect of it, maybe how the syntax or whatever, but actually knowing how to use them is the most important aspect of it. So understanding how the syntax works also is pretty helpful, but let's see how to use them. So let's go over an example, not to use the Windows function. So in this case now, let's say for instance, you want to compare the minimum score and maximum score from all the records in the table we created earlier on this table. So we want to compare the minimum score. Let's say we want to compare the minimum score here. I want to see the minimum score here. If I click on it, it just regroup it. Let me just run it again. You can see now it is now. So if you want to compare the minimum score, you see the minimum score and maximum score from the record here. Yeah, we have here. So if I just run this simple query here, which is going to be maximum and minimum score from the student table, just right, we just select the maximum and the minimum score. It just return these two fields. You get it now, just those two fields. It's as straightforward as that. But do you know that you can also achieve this with a subquery? If I run this query here, saying the maximum and minimum score from the student table using subquery. So this subquery is kind of complex. If I run it like I'm still selecting the whole record. This selector is selecting the whole record from the table. But we want this subquery to now show us the minimum score and the maximum score from the actual table. If I run that, you can see now. So the first row here is selecting this whole record for us. This whole record here. I want to select that this whole record here, which is our initial database. So that's what this first box is doing here. This first query here, first line of code rather, is doing there. So this second line now is a subquery showing us the maximum score and the minimum score from this score column. You can see the maximum number here is 90. So it is expected to return 90 for every rows in that section. And we'll come back to the excess of Windows function. We want to explain the excess of Windows function in this case now. You can see the minimum score is 65. But we can also achieve this same code, this same result rather, with this maximum score, minimum score using a Windows function. So rather than just specifying select maximum score, minimum score from student score, or using this subquery here called maximum score, minimum score, and select star, we just write a simple over, this over statement. We just write the maximum score over minimum score over. So this as is just to rename the field, the column header. As if I run this one now, I'm still going to get same results. You can see we still arrive at what same result set as before. So those are the essence of the over clause or the Windows function. Now let's say we want to compare the average score or probably even the maximum score or the minimum score compared to. So let's say we want to compare the average score of our student. We want to compare the average score against the each department. Against each department. Want to compare the okay, let's say we want to compare the student score by department against the average score of their departments. Look at now. So then this window using Windows, you can also do that with a software. But in this case, using Windows function will be much more better and it will make the query simpler to write and easy to read and understand. So that's the essence of Windows function generally. So as this guy said here, that let's go over this. Okay, as you can see, we have the minimum. The system is pretty straightforward. This query here. So remember that not specifying a partition in the overflows will cause all windows to span through the entire data set. So you can watch yesterday's live stream where I was explaining the essence of Windows function. I talked about that. But let's go over this example here. How to use, okay, let's say, also know that the other query can be achieved using software. How to use Windows function with now partition by. So if I use this, if I want this query normally without specifying any other function inside this over clause, we'll just get same results set for all our rows. So that's the essence of that over. Yes, But if you now want to start slicing and dicing the data set or the database to get more information, maybe you want to get the let's say we have different products now that we are selling in our store. We have like five different products. I want to get the average of each product, maybe by let's say we now have those products in categories or even in subcategories. I want to get the average, the product that is the category of product that is driving the most sales, or the subcategory of the product that is driving the highest sales or the minimum sales, so that we can do away with those products and even stock more products driving the highest sales. Then we can start using this kind of calculation or function to do those slicing and dicing of that data set or the database entirely. So that's the essence of this now. When you look at this example now, let's say you want to compare the maximum score to the average score in each department. Remember that when we run this first query, just specify the maximum score, minimum score, then over. Just specify any function in the over clause. Inside this over clause, closing and opening parentheses. But if you start using this partition by, it's going to slice those data sets by the department that we specify. Depending on the database you have, it can be by any column in your data set. You get it now. If I run this query now, we expect that it's going to return the whole record for us, this select, and it's going to return the maximum score as we have here, but it's going to return the maximum score based on each department. For in this data, let me show you, let me just run it pause and see. If I run this query, I can see that our department has been grouped by each department. So the first query here is returning everything for us, the student ID, the student name. Let me run that again. The first line of code, rather, this select star, they return every record for us in our database, and it's also grouping the departments pretty well here. You now see this maximum score. The maximum score is returning the department maximum score for each department. You check it, and this is the score for the biochemistry department for these three names there that we have here. This is their score, but the maximum score here is 85. So our second line of code here, the second line of code here is going to return the maximum score for this department from these three records here, which is 85. Now this average here is going to calculate the average score for that department, which is what? 78.3333. I can round this off with a round function. I can decide to round it off to 2 decimal places, 3 decimal places. But I'll just ignore that. You did get it now. So that's what this partition by is doing. So I put to understand this concept of Windows function better from this resource here on this free code camp website than how it is being explained here on Datacamp. It's quite straightforward on Datacamp, but I didn't actually understand it in the first instance. Probably because I don't know, sha, I just didn't understand it. The course just wanted to just take the course move to the next stage. But they can also test your understanding also with the case study. But I was able to solve the challenge. You can see it's over. So this is the video lesson. This is a code challenge, a code challenge, a code challenge. And I was able to solve three of them and get the 100% mark for it. But still, I didn't understand. So I need to look for another resource to understand it better. Negative now. So as I was saying earlier, though, so that is that has to use the over clause with the partition by function also. If I go back to here now, you can see now. So that's one of the functions of that you can use with over. So there are so many functions you can use with this over clause from inside this closing up. This side is open and closing parentheses. If you don't specify any partition by or any other function there, it just give you the normal query like this, which doesn't actually make sense. You get it now? It doesn't actually make sense. Just returning same record for the maximum score calculated and the minimum score calculated. But if you want to start sliding by other columns, now you want to start analyzing your data sets by other columns from the database or from the table. So you can start maybe even from related tables. If you start using complex join, you get it now. So you can start using partition by in your over clause, which I now understand better from this guy resources there on free code camp, which really makes sense. So you can also assign serial numbers to the database based on their names. You can also do another stuff here. Instead of calculating average, it is not only average that you can calculate some maximum, minimum count of whatever you want to do based on what this overclass is doing for me. As I said earlier, immediately you see overclass here, It's telling that what the calculation or the aggregation function at behind the over clause is not an ordinary aggregation. It means that it is a Windows function. You want to use a Windows function there to slice and dice your data based on other columns in the database. So I come back here now. So let's start roll number. Look at this one and say assign serial numbers to the database based on their names in alphabetical order. When you look at this name of students now, you can see it is scattered there. If I even go back and run the first code just to return the whole record in database, you can see the names. Fine, the student ID is in is serially arranged, but the names is scattered. Maybe it is unalphabetical, it is not ordered in alphabetical order. You can also do that with the what? With the over clause inside the what? Inside a row number or direct now. So if you use this row number now, we're going to order this data set now based on the student name, based on the student name alphabetical order. We're going to assign number instead of this student ID. There will be a new column called serial number. So let me run that and see. And you can see. Now we now have two serial number columns. You can see the name has been scattered there, but this serial number here is being assigned based on the what? Based on the student. You can see in this section we say select star, then assign a row number based on the what? Over the student's column, based on the what? Based on the student's column. You can see G comes with G H I J K L M N O. You can see like that. So that's another way to use the Windows function. I just discovered in SQL. You can also do some rank. You can also rank the observation in a window or rank the student score by their department. So, okay, name this. Let me just delete this comment here. So what this rank? They also rank. You can see. So with the over window function, you can partition it by any column, and you can also specify any function behind the over what? Behind the over clause, which tells the SQL engine that this function at the back here is a what? Is a Windows function. That's what that does immediately. If I do this now, uh, so this one is quite different. This rank function is quite different from this row number function. So they pretty do different, and I'll show you now. If you see the row number now, it's quite straightforward. It's just assigning what serial number to your what to the names to the database based on the column we specify based on the student name here. But if I should run this rank, we want to rank now. We are ranking by partition by department. We are ranking by department. Let's say we want to rank our student scores by first, second, third, fourth. They can use this rank function rather than using that row number function. It doesn't actually, it's not really good in that context though. Doesn't because if I run this on called rank here, you can see select star to return all the whole record from the student table, from student score. Then rank by department. Okay, I'm still ranking by department. Okay, rank by department, order by score. So I'm ranking by department. And this is where it gets expensive. I'm ranking by department, but in my rank function, I will specify the order I want my results to be ordered. So using row number, you don't need to. If you use order by, same thing as row number, you use order by. But if you are, and you notice by in this row number, we didn't specify partition in our what in our over clause. We just say row number order by straightforward. So that's how to use row number function there. But if you're using rank, you have to include partition by, then order by a particular column. So we are partitioning. That means we are, if you, the word partition by, what it does, it's kind of grouping. I think it is kind of grouping the data set based on that column that you have specified. So you're saying partition by department. So segregate those data sets, the database by departments. You can see by departments, then by department, then by department. Even in alphabetical order, you get it now. Then order by score. When you look at this one now, look at the score column, you can see order by score. So it is partitioning the result set by a department, then by the score column. That means from descending, you can see. If I remove this descending here, by default, what we are used to order by, when you use the order by clause by default in SQL, you get to arrange it from smallest to largest. If I run this again now, you can see that what it is partitioned by department, but the score is from what smallest to largest, and it's going to give the score rank this other what this call rank here, the rank that we specify here. Yeah, so what happens is that even the Windows function doesn't work except after what the first was this first over clause partition by clause have worked, then the rank function will now come into existence. You can see 70 is it has a rank of 1, which is wrong, which is supposed to be 85, which is the highest score here. So we have to specify what descending clause there. The descending clause there. If I run that again, and so now it is now the flip side. So 84 is the highest score in the biochemistry department for these students. So 85, then 80, then 70. When you look at this computer science, this computer science, you can see the highest score in the computer science department is 90. It has a rank of 1, then 80 has a rank of 2. We have two students that score the same mark, which is 80, 80, and they both have the rank of 2. But the rank of 3 is skipped. So to escape that, I also know that to escape that, you can just use instead of assigning two second position, so maybe the rank of two rather. Let's use the second position to the two values of 80 here, and it is keeping 3, which doesn't really make sense. But you can also get now. This is the third one. If you are in school, if you're in a school setting, when two students have second position, there won't be a third position. So it's just jump to the fourth position. So it makes sense there. It is in like that. But if you want it to just assign two second position to these two values and just assign a rank of 3, you can just use the dense rank function, which also does the same thing. If I use the dense rank now, if I use dense rank there now, you can see now that it assign, if you come back to computer science now, assign the value of 1 to 90, rank of 1 to 90. You can see now for computer science 80 score, rank of 2. Then that 67 is now having a rank of 4. So it's not splitting 3 now. It's what it is using, it's actually using 3 there also in the ranking. So that's all I could learn, and I think it's really interesting. It was really understanding using the resource here from this data free code camp to understand the over function pretty much more better. So I think I stopped here when I was doing the learning offline. I stopped here under how to use lab function after testing the code. But there's another part here that I didn't understand in this. If I go over to this first lesson here, if I go back there, if I play the lessons first, there was a place they were talking about bounded, unbounded.
Great job. You now have experience transforming data using simple subqueries to functions that perform.
Let me fast forward it and see.
Chapter 2, where a sub creates a column numbering your data set from highest to lowest or lowest to highest based on a column that you specify. Let's take the same query as the previous example. To create the rank, you start with the rank function using parentheses followed by the over clause. Inside the over clause, include the order by clause.
So I now understand this rank over order by Yongo better, really better than she explained here using these resources here. But there's a place she was explaining partition by. Oh, so if I just skip this section, if I skip it to the end here.
Okay, let's practice some simple window functions using the over clause.
So let me skip it to the end there. So I've gotten so where are we? I want to see where the stuff was dropped. Oh, the match is over. So this is a simple query though. So we are selecting, if I skip this select, which is quite straightforward. If I come to this average home goal plus away goal over, so what we expect is that it's just return the average home goal and away goal over the what? Now it will now calculate this overflow is going to calculate the overall average of adding this home goal and away goal from the match table. If I run the code now, Let's see. Oh, I'm selecting the wrong code. Now see this overall average now. Consider that it is same result from the one I used, the example I used there when I was doing the example here. You can see this maximum score I was using earlier. As in, it is returning same result. It's just taking the what the maximum score here. Returning is for every row and the minimum score. So same thing that is happening here. You can see. So the overall average is what the addition of this plus this, then the overall average of that column is giving us this. So that's pretty straightforward there. Even though this one is more, we are now using join. We are joining two data, which I pretty much understand from the previous lesson. If I skip that now, I press Ctrl Shift or submit that. I've done this section before, so the code is now well understood. Now, look at this one. Now we're not using rank again. If I run this code, I can see average home goal plus away goal as average goals. Now we're using rank plus over, then order by. Since we are using rank, now we want to rank the goals from what? From yes, this is going to rank it this by default from lowest to highest. If I run the code now, this function, this rank, as you can see the highest average goal here is 3.2, which is having the rank of the lowest rank. You get now. While the lowest number here is having the rank of the highest rank, league rank. Based on the word rank, close and open the bracket, over, then order by the average home goal. You can see we order it by the word this average home goal calculated, home and away goal calculated as league rank and stuff like that. I submit that and that is well understood. Super. So that is the essence of you have to understand what is happening within the database so that you won't just memorize code. You just want to go and pour it out in another place. It doesn't work. It's not advisable to learn like that. Now, it's okay, you just did descending. So to make the last code correct it very well, it is not, we now have the descending clause here. The same way I did here in my data set of rank. Let me show you that. I see the rank, my rank stuff. I rank the student score by their department. If I run this code here, you can see now we've ranked them by each department from first, second, third. The highest score here is 85, 80. So that's why this descending clause is there. Can you see now? So that is what is also happening in this case here. If I run the code now, the code will now be flipped. You can see now it has been flipped. The highest will come first. It has the rank of 1. Then the lowest will have the rank of the lowest ranking. Because if I submit it, and boom, I understand this rank function and the over clause. Now where it start getting interesting, the partition by, but I also understand that now. The over with partition. I understand this section also. I understand this section of partition by better now. Over with partition by colon, partition by multiple. But where I didn't understand is this sliding side. But there's something that was mentioned here that is not really, I didn't really see it here also. First. Oh, when I get to sliding, I think the guy, I saw the resource there. Okay, let me play this one. This partition is also simple to understand.
You've done a great job working with the over clause so far.
It's also simple to understand earlier, but after I read this article, I was able to understand the partition by how it works also. And I think I showed some example already earlier from here. So I did partition by department and stuff like that. Partition by name. I was able to understand that better using the resources here. Let me just listen to it one time.
The real bread and butter of window functions that differentiates them from subqueries and select are in the functions you can add within the over clause. One important statement you can add to your over clause is partition by. A partition allows you to calculate separate values for different categories established in a partition. This is one way to calculate different aggregate values within one column of data and pass them down a data set instead of having to calculate them in different columns.
Oh,
The syntax for different categories working with the over clause so far. The real bread and butter of window functions that differentiates them from subqueries and select are in the functions you can add within the over clause. One important statement you can add to your over clause is partition by. A partition allows you to calculate separate values for different categories established in a partition. This is one way to calculate different aggregate values within one column of data and pass them down a data set instead of having to calculate.
To calculate separate values for different categories. So that's what we did. They've calculated when you see this example, we calculated different categories: biochemistry, computer science, and by department. And we calculated different categories. Maybe probably also calculate the if I had the average score here. Let me make it interesting also. I think we did that earlier. If I come back here and now add this average calculation to it, like this average calculation, I copy it. I'll come back to my rank here. This is now getting interesting. I come back to my rank here. See now I have average score over partition by department at department, but there's still ranking here. Let me put it there. Let me put it here over the. Let me put it here. So if I run this code now, let's see. Aha, because we have the department average. Because I've calculated same from one result from one query. We're able to perform a calculation, at least two different calculations. The average score by department and the rank of the score by that department. So that is the essence of this partition by, and that's what she was trying to say here. But when I was listening to this earlier, I didn't understand it. It didn't sit well with me. Also, I started researching now.
Calculate them in different columns. The syntax for a partition is fairly simple. Just like before, use an aggregate function to compute a calculation, such as the average of the home goal column. You then add the over clause afterward, and inside the parentheses, state partition by, followed by the column you want to partition the average by. This will then return the overall average for, or partition by, each season. Let's take a look at how this works in a query. This example query from the previous lesson answers the question, how many goals were scored in each match, and how did that compare to the overall average? This is accomplished using the over clause, and the query returns the date, goals scored, and overall average. Let's expand on the previous question and instead ask, how many goals were scored in each match, and how did that compare to the season's average? We can do this by adding a partition by clause to the over clause from the previous slide. Okay. Specifying partition by season returns each season's average on each row in accordance to the season that each record belongs to. As you can see, rows 1 and 2 are matches played in the 2011-2012 season.
I understand the partition by clause better than I did earlier. You can see the average on goal plus away goal over. That shows that what the over clause immediately tells the SQL engine that what the average result here, the average function here is not an ordinary average function. Then partition this average calculation by that means this average should be calculated by for each season, not the whole rows in the data set. Now it's going to go by season, this
season. And the season average column contains the 2011-2012 season average. Rows 3 and 4 are part of the 2012-2013 season and return the 2012-2013 season average. You can also use partition to calculate values broken out by multiple columns. In the query you see here, the over clause contains two columns to partition the average goals scored, season and country. The result set returns the average goals scored broken out by season and country. In row 1, a match was played in Belgium in the 2011-2012 season and had 1 goal scored throughout the match. This is compared to the value 2.88, which is the average goals scored in Belgium in the 2011-2012 season. Partition by is a pretty straightforward addition to the over clause. You can partition calculations by 1 or more columns as necessary to answer a question you may have. Additionally, you can use a partition with any kind of window function, a calculation, rank, or others that we will discuss further in the following lesson. For now, let's practice calculating window partitions on our match data.
Yeah, so you can use that partition by with anything, rank, sum, and so on. Exactly. So yeah, let me just do this. I can do this perfectly right now. You can see this select date, okay? And here, partition by a column, partition by multiple column. So I come over here now, please, when home team ID is 8673, then home else away enders also location. So clear the average goal scored partition by season. So average goal. Now this one is average. Immediately, once I play the average goal scored. So if I go to the from March, that is average home. So that will be home goal. Home goal. Then over. We have the over clause there. Then partition by season. Let's see partition. Partition by season. Then we have the average, same average calculation here. The away goal. So we want to calculate the away goal. Away goal. Then introduce the over clause. So that is the Windows function. Over clause. Then partition by season. I can just copy this here to save time. I just copy that there. So from March, filter the data set for Warsaw matches only. So you can see where home team ID. You can just copy the home team ID here. Where the home team ID is this, and the home team or the home team or the away team ID. I can just change this one to away team ID here. Away team ID. Away team ID is that. So if I run the code now, that should work for you. You can see now we have our cool calculation currently. I can just submit that. And boom, we are correct. You can just press enter to submit that. Now same calculation, same thing. Let's say calculate console two Windows function, partitioning average of home and away goals by season and month. So by season and month, I think I've done that. So I've done this already. Calculate the average partition by season and month. If I extract month, if I run the code, and boom, I've done that. So we can say home goal over partition by season, comma now extract month from data, season, month. If I submit that, that was pretty straightforward. So that's partition by. I have a good understanding of partition. So what I don't understand is this sliding. Because under this sliding, they were mentioning something like preceding, following, unbounded preceding, unbounded following, which was, and I think I saw that result.
In addition to calculating aggregate and rank information, window functions can also be used to calculate information that changes with each subsequent row in a dataset. These types of window functions are called sliding windows. Sliding windows are functions that perform calculations relative to the current row of a dataset. You can use sliding windows to calculate a wide variety of information that aggregates one row at a time down your dataset. Running totals, sums, counts, and averages in any order you need. A sliding window calculation can also be partitioned by one or more columns, just like a non-sliding window. A sliding window function contains specific functions within the over clause to specify the data you want to use in your calculations. The general syntax looks like this. You use the phrase rows between to indicate that you plan on slicing information in your window function for each row in the dataset. And then you specify the starting and finishing point of the calculation. For the start and finish in your rows between statement, you can specify a number of keywords as shown.
And these are the keywords I don't actually understand. This preceding, following. But I saw these guys, this article explanation, also explaining them better. So I'm going to stop my light. I can see this is a preceding, following, unbounded preceding, unbounded following, and current row. So this guy did justice to this Windows function in here. So I'm going to use that resource and practice it first with my simple database here. If actually coming back to Datacamp and using this their own actual database with their joins clause and all that properties. So I would love to end the live here today. So I'm going to be completing this of live. So thanks for staying to the end of this live section. So if you're really interested in becoming a top rated plus freelancer like me, or starting your own freelancing career, or even be the top 1% freelancer in the world, I will encourage you to check out a course by my coach. So I have a coach that has been putting me through freelancing for the past years. I've been in freelancing career. So his name is Benga Debi. He has a course called the Freelance Client Magnet course, which teaches you how to become a successful freelancer on Upwork, Fiverr, LinkedIn, Emojo website, and even using your social media account to start applying for jobs to position yourself for opportunity for job opportunities in the tech space or in the online space generally. As you can know, everybody uses their social media account now to what? To sell something or to sell their services or products. You can check out Benga this vehicles under the YouTube description. It's called Freelance Client Magnet course. If you purchase this course, you gain access to Benga Debi's resources himself and his one-on-one coaching. Sorry, his weekend coaching. So his one-on-one he also offers one-on-one coaching, which will be his one-on-one students. And you have access to him 24 hours a day, 7 days a week, as long as what you can afford it. But also, if when you purchase this course, you also have access to him on weekend. He does weekend support session where he teaches you all you need to know about freelancing, what to do, what not to do, and how to scale your freelancing career to the next level. I'll leave a link also to Bengali BE Twitter account under the YouTube description. You can check out Bengali BE on Twitter to see the work, to see his testimonial. You can just search on the search bar. So this is him here. So you can check out his Twitter profile. You see a lot of testimonials there of students who have made millions and millions of dollars from what? From his freelancing knowledge. So check out the course, check out Bengali BE testimonials on Twitter. Then you can purchase the course. Use the link in my bio to get 10% off your purchase. And I'll see you tomorrow, same time. Don't forget to put on support the channel also and put on the and subscribe to the channel and turn the notification bell on so you know every time I go live, you can join me live and we learn together and become a data analyst and make money from this tech journey we are trying to make. So thanks for watching, thanks for staying to the end, and I'll see you same time tomorrow. Bye for now.